Okay, last time we developed x prime and y prime, and we're going to see why that's going to be useful here coming up. So now let's see. So we found out using this point, notice these two are equal, but we found out using this point how to define this point in terms of the x prime and y prime axes. But now let's define this point in terms of our original x and y. So I'll just write, I guess, define in terms of xy now. So down here I have another triangle. So this is like a different triangle. If we look up here, so we did this red triangle here that follows this. We did that. Now let's do this black triangle that defines the point in terms of some x value and some y value. And let me pull that off down here. So now we have this triangle. So this is the same point, and again this is our origin 0, 0. As before, it was the same origin as we had up here. This was the point we defined as x prime y prime, but it's also the point xy, where we have some x value and some y value. You go some x distance, some y distance you get here. Again, this is our, it's the same radius. It doesn't change. The length of that line doesn't change. So now the difference was, though, that in order to get the angle here, this was an angle of theta, and this whole angle is going to be theta plus alpha. So in the same sense that we developed x prime and y prime up there, we'll have an x is going to equal r cosine of theta plus alpha. And actually, not that it matters, but just the way I want this to work out, we're going to do this alpha plus theta, and y equals r sine of alpha plus theta. So we have the sum of two angles here in a sine and a cosine function, and we learned before how to deal with that. We have the sum difference rules. So if x equals r cosine of alpha plus theta, I guess I reversed them around in my notes again, so I'll do the same thing here so I can follow my notes and more easily do this. Check my answers. Theta plus alpha, that's going to equal r times the cosine of theta cosine of alpha minus the sine of theta sine of alpha which equals, so r times the cosine of alpha is defined up here. So we pull it out, r times cosine of alpha times cosine of theta minus r times, and r times the sine of alpha is up here too, times the sine of theta. So essentially x equals r cosine, let's stick this back in. x prime. Our cosine of alpha is x prime. If we look up top here, x prime times the cosine of theta minus our sine of alpha is here, y prime sine of theta. So there we go. Now we have x. We have a formula that converts from x prime and y prime into x. Tells us what the x value is. Likewise, we could do the same sort of thing, and we will find that y equals, we can use a different some difference formula, x prime sine of theta minus y prime cosine of theta. So there you go. So what does this mean? This means that if you have, say, an ellipse that's off axis like this, say that's centered here, it doesn't even need to be centered there, but you have an ellipse that's off axis and there's a point here, and you have x prime and y prime, and we know there's some theta. Let's say it's theta 55 degrees, for example. And we know maybe that that x prime, say, equals 2 and y prime equals 1. So it's a distance in the perpendicular distance towards the y in 1. So it's 2, 1. And we know the angle of the theta. We could calculate what the x value is. So like x is going to equal 2 cosine 55 degrees minus 1 for y prime sine of 55 degrees. So that's going to be our point in terms of x and y now. So we have a conversion formula that converts from x prime to y prime. Well, because we have that, we can use it in reverse, and that's how we're going to use it to solve our problem. If you recall, in our problem, theta was equal to 60 degrees. Excuse me. So, in our problem, x equals x prime cosine of 60 degrees minus y prime sine of 60 degrees, which x prime cosine of 60 degrees is going to be x prime times 1/2 minus y prime sine of 60 degrees is going to be square root of 3 over 2. And y then in our problem will be x prime sine of 60 degrees minus y prime cosine of 60 degrees, which is going to equal x prime, these will end up being reversed, square root of 3 over 2 minus y prime times 1/2. Okay, so we have a system of equations now with x related to x prime and y prime by these factors, and y related to x prime and y prime by these factors. So how do we continue? Well, you recall, let me just say this and then we'll stop here. You recall, and continue with in the next video, you recall our relationship is x squared plus square root of 3xy plus 2y squared minus 10 equals 0. So our relationship is in terms of x and y's. Well, we want to convert this into terms of x primes and y primes so that we can just plot our ellipse that way. So we can plot our ellipse in terms of we can plot our ellipse as though it's in terms of this x prime and y prime at an angle, and we'll know that this angle is 60 degrees. And we're going to do that next.